Liquid repellent surfaces can be found in nature or in the man-made environment. Insects have evolved complex surface microstructures to repel liquids, which could inspire future surfaces for functional applications. Medical devices, for example, could benefit from materials that direct liquid flow. In an article in Advanced Materials, Professor Chunze Ku and colleagues from Southeast University in China utilised direct laser writing to 3D print omniphobic surfaces that can universally repel organic liquids, which could find application in microfluidic devices and sensors.
Liquid superrepellent surfaces have attracted much attention due to their academic and economic value. Inspired by the spring-tail scheme, we have fabricated triple re-entrant structures by two-photon polymerization.
The surface design was programmed into a 3D printing system, and the microstructures were then written layer by layer into a negative photoresist via laser-induced photopolymerization. The resulting triply re-entrant structures could be constructed on a target substrate, including a rigid silicon wafer or a flexible polyimide film.
These structures show super repellence to water and almost all organic liquids we found.
The structures also exhibited anti-adhesion and anti-spreading of various liquids, including water and N-perfluorooctane. Directional liquid flow was demonstrated by constructing a channel on the array. The droplet of R6G dyed ethanol was drawn along the parallel walls of the channel by capillary force, without spreading, demonstrating the potential of these arrays for functional applications.
The method shown here can find a number of applications in microfluidics, electronics, and biological sciences.
To find out more about triply re-entrant structures for directional liquid flow, please visit the Advanced Materials homepage.